Of course, a warm welcome to everybody from Germany to today's webinar with Dr. Giacomo Savini from Bologna in Italy. As you already mentioned, he's a board member of the IOL Power Club, a circle of experts dealing with all kinds of issues around IOL power calculation. So Giacomo, welcome. And thank you for taking the time to give this lecture for today's webinar.
Thank you.
And before we start, I want to remind every attendee to address questions regarding technical issues using the chat function that you see. And we have colleagues in the background who will immediately answer and trying to help you. All other questions, please address to us via the question and answer, the Q&A function, and we will try to address all these questions at the end of the webinar to Dr. Savini. And what we are not able to get answered, we will do this via email. So the title is IOL Power Calculation with the Pentacam AXL and Pentacam AXL wave. So Giacomo, please share your information with us.
Thank you. Well, we will cover different topics because I would like to give you an overview of the basics of IOL power calculation. We will see the results of IOL power calculation by the Pentacam AXL in unoperated eyes, something that has not yet been published, but I will show you the data that we already submitted to JCRS. We will talk about toric IOLs calculation, IOL power calculation for post-LASIK and post-PRK eyes. I will give you some practical suggestions to use successfully the Pentacam AXL and any kind of Pentacam in your daily routine. And of course, I will be happy to share with you our first experience with the Pentacam AXL wave that I've been using since this year. The big problem of IOL power calculation is that now you have so many formulas that it is difficult to understand which is the right one to choose. Because until 2010, we had just 4 or 5 formulas that everybody knows, the SLK2, the SLKT, Hofer-Equivalent, the 1 and 2, and Hygis. And this was everything until 2015. In the meanwhile, many new devices, many new optical biometers were becoming available, so the technology was getting better and better, and we were still relying on formulas that were 20, 25 years old. Since 2015, there's been a kind of explosion similar to what happened 10 years before for post-LASIK formulas. And now you see all these names. Probably many of you do not know some of these formulas. Probably they do not all deserve our attention, but it's something that you will listen to in future meetings and future devices. This is a slide of my friend Hofer that explains the basics of all formulas, even unpublished formulas, where P, the power of the lens, is obtained by divergence of the rays behind the lens, behind the IOL, minus divergence of the rays from the cornea to the IOL. Just to give you a better impression, the first part of the equation is this one, from the IOL to the retina. The second part is from the cornea to the IOL. So here we have about 70 diopters that then you have about 40 diopters, or 45, sorry, and then you have to subtract what happens behind the lens. Where do all these formulas have a difference? The difference is this term that Hofer calls the IOL position. That is what we are used to call the ELP, the estimated or effective lens position, which is different in each formula, because more or less the corneal power and the axial length and the refraction and all the other data are very similar. There are small differences, but very small. And when we talk about regular formulas, we have a difference, because we see that some formulas, like the Hofer Q holiday 1 and SRKT, use just two predictors to predict the position of the lens, while newer formulas, not the last one, use other parameters. The Haigis formula does not rely on corneal power to estimate where the lens will be positioned, but uses ACD, and this makes a big difference for many cases. And the Holiday 2 that was released in 1996 and has never been published, you see, it uses a lot of preoperative parameters, and has the optional also of adding the preoperative refraction. You all know the old formulas. These are the guidelines that Dr. Hofer has been highlighting for many years, where if you just want to stay on the standard formulas, you should use the Hofer Q for short eyes, shorter than 22. For the average of the for the medium eyes from 22 to 24.5 millimeters, you should use the average of the three formulas. For the Holiday 1, this formula should be applied to medium long eyes, and for long eyes the SRKT. This is not an invention. This comes from a study that he published in 2000 on JCRS, when he was the first to publish the results of the Holiday 2 formula, and he saw that the Holiday 2 was good, but was not superior to any other formula. Then he added that the Haigis formula, when you have triple optimization of all the three constants, is valid in all groups. And please, if somebody is still using the SRK2, please delete it. Even the authors have stated this several times. This is just a pure regression formula with no optical basis that may be quite appropriate in medium long eyes, but should be abandoned. And I just told you before that the Haigis formula makes a difference based on the fact that it predicts the IOL position from the ACD rather than the K. And a clear demonstration comes from this paper that compared the Haigis and the Hofer Q formulas in short eyes. And what did they find? They found that if the ACD, the preoperative ACD, is higher than 2.4 millimeters, there's no difference between the Haigis and the Hofer Q formula. But when the ACD, that is measured from the corneal epithelium to the lens, to the anterior surface of the crystalline lens, the Haigis becomes more accurate than the Hofer Q. Not a surprise. ACD is a parameter to estimate the lens position in the Haigis, while the ACD is not used by the Hofer Q. So for the Hofer Q, a 21 millimeter long eye with an ACD of 3 or 2 millimeters is the same. For the Haigis, not. When using standard formulas, you should also take a look at the other parameters like the corneal power. You see in this graph published by Ron Melles 2 years ago in the big study of 13,000 eyes, that the SRKT that is in the black line produces an hyperopic error in eyes with flat corneas, whereas it produces a myopic outcome in eyes with steep corneas. So be careful when using the SRKT in flat or steep corneas. Other formulas have a different behavior. The Hague is the opposite one, although to a lesser extent, while other formulas like the Barrett, here red, has a very little influence. Some influence comes also with the ACD measurements, because the Hoffer Q probably is the most affected. It produces a hyperopic outcome with eyes having a very deep anterior chamber and a myopic outcome in eyes with a shallow chamber. And as regards the lens thickness, the Hague's formula is affected to a higher degree and produces a myopic outcome in eyes with a thin lens and a hyperopic outcome in eyes with a thick lens. But now we have also all these other formulas. I will not talk about any one of this because it would take too much time, and I have to talk about the Pentacam AXL wave and not about the formulas. If you want to take a screenshot, then you can go and use most of them for free on the web, as you can see from these addresses. You all know the Barrett Universal 2. The EVO 2.0 is a formula partially based on artificial intelligence developed by Dr. Yeo in Singapore. The Kane formula is becoming one of the most interesting formulas from Australia. I also included the Holiday 2 formula because Holiday last year published a letter on JCRS January 19 showing an axial length adjustment for eyes longer than 24, and this significantly improved the prediction of the Holiday 2. So we consider this now a new Holiday 2. The last one is the LADAS Super Formula 2.0, which is totally different from the original LADAS formula, which was a combination of the Hoffer Q, SRKT, and Holiday 1. This is totally new and is based again on artificial intelligence. The NASER 2 has been published 1 year ago. Is a thick lens formula. Is published, so you can do it by yourself on Excel if you want. The Olsen formula is quite known, is available on many biometers, or you can buy the full software at FACO Optics. The Pearl DGS is another formula that has been released in 2019 from Dr. de Belmanière and Gatinel in Paris. The RBF has been developed by Dr. Hill and has been the first artificial intelligence formula. And finally, the VRF comes from Ukraine. There's a software, and you can read it on the January issue of the American Journal 2 years ago. So, what did the literature show during the last few years about these, or at least some of these formulas? There have been 3 landmark papers. The first one was released in 2016 by Kane on 3,000 eyes with the Alcon SN60WF, and he found that the best formula, and he was the first one to show this almost 4 years ago. And as you can see in the red square, there's the percentage of eyes with a prediction error within half a diopter, which is what we call a clinical success. And the Barrett formula had the highest percentage, 72.3%, higher than the old formulas. And this is a parameter that has been more and more important during the last years. And he was really the first one to show this on a relatively large sample, 3,000 eyes. And in the same year, Dave Cook found the same. He did a comparison. While Kane used just the old IOL master, he used both the IOL master and the Landstar, and he found again that the Barrett was the best. So in the same year, two papers showing that the Barrett was the best. Then he also provided the Landstar data, which measures the lens thickness, and the Olsen formula, the one from Phaco Optics, was the best, because the one from the Landstar was slightly worse, because on the Landstar there is no information. The position of the lens is not predicted from Ka and axial length, but only from lens thickness and ACD. And again, Barrett in second position. Then 2 years ago, Melles and Holliday published the largest study so ever on 13,000 eyes, always with the same IOL model, and again, Barrett first, Olsen second. So based on these three large studies, I think that we cannot exclude from our calculation the Barrett and the Olsen formula. And what about Pentacam AXL? Well, there are not yet published papers. I hope that ours that have been submitted 1 week ago will be soon available, but I want to share with you our results. Originally, we included three IOL models, the monofocal SN60WF. Then we did some preliminary studies also with the toric monofocal and with the Panoptics. I will show you in detail the results of the monofocal one, because it's the same lens that has been used by Kane, Dave Cook, and Melles. So the results are comparable, as the model lens is the same. We use the data from the Pentacam AXL that can be seen in several displays. This is the first display that comes available, where you see all the data that we need, included axial length here, and K1 and K2 and ACD. This is the printout that is useful for the clinician. It's not useful for the clinical studies because we use other measurements, but when you are in your operating room, having this one, of course, is a good advantage. And it took some time, but we wanted to test all formulas, even those that are not yet included in the Pentacam, because they have been made available maybe just 6 months ago. So we included the Barrett, Evo, Haggis, Officura, the one or the two with axial length adjustment, the Kane, Ladas super formula, Naser 2, Pearl DGS, Hill RBF, SRKT. The T2 that has been, is not a new formula. It dates back to 2010, developed by Dave Cook and other authors to improve the SRKT, but it had no popularity, even if it's a very good formula. And finally, the Ukrainian VRF. And for each formula, we calculated the prediction error as the difference. Please try to remember what this is. It's the difference between the measured and the predicted postoperative refraction. The predicted, not the target. Target is something different. The important issue is what the formula, the refraction that is predicted by the formula. Then a negative prediction error indicates more myopic results than the predicted refraction, and the positive one, of course, a hyperopic error. For all these formulas, we did constant optimization. That is something that everybody knows, at least heard about it. What does it mean? It means that the mean prediction error for each formula has to be zeroed out, so that if you have patient 1 that becomes +1 and the second +2, you have to adjust your A constant so that on average the arithmetic prediction error is 0. For published formulas, Holiday 1, Hygis, Hoffer-Q, and SRKT, this is not difficult if you play with Excel. For all unpublished formulas, we had to ask help to the authors because they don't give me their Excel files. And please remind that this can be done on the Pentacam AXL once you have the patience for each patient to enter the implanted IOL power and the 1 month post-operative refraction. Then the machine gives you the optimized A constant and whatever. And the main outcomes of this study were the median absolute error and the percentage of eyes with the prediction error within a quarter and a half diopters. Not everybody knows what the median absolute error is. Just give me a few seconds to explain. If you have 2 patients and one ends up -5 and you are not happy, and the other one ends up +5, the result is that the arithmetic error is 0, and you may be happy about this, but you have 2 very unsatisfied patients because one is -5 and the other one is +5. So in this kind of studies, you have to rely on the absolute error, which is 5. And so we had to consider the absolute error. This was our study, and these are the results. And you see that with almost all formulas are have a prediction error higher than 85%. Look at the data of the Barrett of the Mellis study, and the best formula was the Barrett with 80%, with the IOL Master, and we are all over. And even more interesting is that with all formulas, we are at about 50% of eyes within a quarter of diopters, and surprisingly, the per DGS was the best one. And the median absolute error was with the best formulas around 0.2 diopters, but all formulas had excellent outcomes. And these are the results with the per DGS, LS, LADA super formulas around 0.2, but even the worst one had excellent outcomes. With, again, all this data with the best formulas around 85–86% of eyes within half diopters, and even the worst, the traditional one, Hoffer-Q, Holiday 1, Holiday 2, around 82. So all these formulas, this is true, all these formulas behaved better than all the formulas of the Mellis studies with the IOL Master. These are the results for the toric and the panoptics, and look, I did not do such an extensive analysis, but we had an unbelievable, really unbelievable percentage of around 90% of cases within half a diopters. So using the standard case and all the measurements by the Pentacam AXL, based on our data, demonstrates that you can achieve excellent outcomes if you optimize your constants. Of course, we cannot tell our patients, we are not yet able to say that we are perfect, so do never make the error of say to your patients that you got 100% of cases within half a diopter. There's still a 10% of cases, around 10–15%, that will end up with a prediction error higher than half a diopter, and especially with multifocal IOLs, this is a problem because in a few percentage of cases, you may end up with the need for a LASIK enhancement. Topic 2, toric IOLs. We did several studies. You need to know that the Pentacam provides you with many options. The 2 options that, in my opinion, are the most interesting are K1 and K2, the standard Simk that uses just anterior corneal measurements and estimates the total corneal power by means of the keratometric index of 13375 and total corneal refractive power and astigmatism, which takes into account the measurements and not any estimation of anterior and posterior corneal curvature, and then makes calculation through ray tracing of the real corneal power. And this is very useful for toric IOLs. You see here both measurements. We know there have been several studies about posterior and total corneal astigmatism. We know that the posterior meridian of is almost always vertically aligned, and such alignment generates an against the rule astigmatism, which partially compensates anterior with the rule astigmatism and increases anterior against the rule astigmatism. Just an example where you see that K1 and K2 here show you an astigmatism of 1.4 diopters in an eye with the rule astigmatism. But if you take the total corneal refractive astigmatism, it drops to 0.6. And in an opposite case with against the rule astigmatism, K1 and K2 underestimate TCRP. This is an irregular astigmatism, but you have 1.9 diopters against the rule with K1 and K2. But if you see the power distribution display showing the total corneal refractive power, you go up to 2.8. This is not philosophy. This is real clinic where you have to totally change the choice of your toric IOL. And we did some studies. On average, the difference between Simk and total corneal power is about 0.2 diopters, but you cannot rely on some kind of adjustment, the same for all eyes, because there's a correlation in eyes with, as you can see from this graph, which correlates posterior corneal astigmatism to keratometric, which means Simk astigmatism. As expected, eyes with low keratometric astigmatism have low posterior astigmatism, but if you go to an eye with 5 or 6 anterior keratometric astigmatism, of course, also the posterior one increases. And we did a first study on the usefulness of total corneal power in 2015 with Dr. Neser from Denmark, and we were the first one to find that using total corneal astigmatism provides some clinical significant and also statistically significant advantages. Just look at this number. In eyes with the rule astigmatism using K1 and K2 and his vector analysis, we got an overcorrection, an average overcorrection of of 0.59 diopters, and an overcorrection, sorry, and an undercorrection in eyes with against the rule astigmatism of 0.32. This using K1 and K2 as we all did in 2014. Then using total corneal power, the error, the average prediction error, dropped to -0.13, and in eyes with against the rule, it dropped down to 0.07. These numbers that were obtained with the toric AXL were for all eyes with temporal incision. We do not make the incision on the steep corneal meridian because this makes easier the calculation of the surgical induced astigmatism that I will not talk about this, but everybody using toric IOLs should know which is. We use a 2.4 millimeter incision, and we found that it is 0.2 diopters, of course, in the opposite direction of the temporal incision. And here the first example where you see that there's a difference between here 0.7 diopters of K1 astigmatism between K1 and K2 and 1.2 using total corneal power. 0.5 diopters is a clinical significant difference. And we relied on the 1.2 astigmatism from TCP, and we implanted the T3 that corrects 1.06, got a final planar refraction. Had we used the T2, we would have obtained a small, but anyway, a cylinder under correction. A second example where we used several devices, including the Pentacam, and when we relied on the K1 and K2, you see that all instruments provide about 2.5 diopters of astigmatism at around the same 68, 70 degrees. But when you go to the Pentacam power distribution and you see the total corneal astigmatism, it is 1.8. So almost 1 diopter of difference. This is not the same toric IOL. We relied on the toric calculator that is available on the Pentacam, and you see you just have to select the IOL model, the IOL formula for the spherical equivalent that is given here. You can use the toric calculator. You have two toric calculators, the one that I developed based on total corneal power and astigmatism. And then from this you get this is based on the total corneal refractive power at 3 millimeters based on the zone measurement and pupil centration, but you don't have to worry about this. This is automatically given by the machine. And finally, you got the T5 choice. We implanted the T5, got planar refraction, but image which kind of overcorrection we would have obtained if we used the K1 and K2 showing 2.8 diopters of corneal astigmatism. There have been later some studies showing that if you use the Barrett and other calculators that estimate total corneal astigmatism, you got slightly better result than using direct measurements, but the latest software by the Pentacam was able to zero out this difference as shown by this data. And you see that the eyes with an absolute prediction error of the cylinder lower than 0.75 diopters is 67 versus 68 diopters between total corneal measured value rather than that the Barrett calculator. So in conclusion, total corneal astigmatism improved the results of cylinder correction with respect to keratometric astigmatism based just on the anterior surface, and the Savini's toric calculator, which is simply the use of total corneal astigmatism by Pentacam, makes calculations more accurate and is easy to calculate. So, and these results are very close to the methods using estimated total corneal astigmatism. But please remember that estimated methods like the Barrett are good for average eye. For irregular eyes, I'm not talking about keratoconus, just irregular corneas, all the estimations are no more valid. Third chapter, post-LASIK calculation. The Pentacam has been introduced as one of the first devices to provide this kind of information, and a few months ago we published this paper because there was a new formula, the stop formula, that had been developed, and we wanted to test it also with the Pentacam. This was our sample of 50 patients where you see the average data. Of course, the axial length was slightly higher. These were myopic eyes, 27 millimeters. In 27 cases, we had the pre-excimer laser keratometry because the patient had a clinical chart. In 23 cases, we estimated the pre-excimer laser keratometry using the method that I described some years ago on JRS. This, knowing the preoperative K is important for formulas using double K. And these are the results. And again, go to these numbers. You see that with the triple S formula, which is an adjustment made maybe of the size Spiker Savini formula, easier to call it triple S, and with the masked formula, which is available on the ACRS website, you got 70 to 76% of eyes with a prediction error lower than half a diopters. These numbers would be good even in unoperated eyes. And then many other formulas were above 60%. Surprisingly, there was a fair result with the Barrett formula, but I will talk about it later. And if you see the median absolute error, again 0.3, even with the stop formula, was excellent, especially because we are not talking about medium-long eyes, we are talking about long eyes. Of course, Barrett was slightly disappointed with the fair results of his formula. Then we discussed, and from any constructive discussion, good ideas becomes true. And we discussed that the formula that I used on the Pentacam was the fully no history Barrett formula. But Barrett formula has 4 options: full no history, or you can use the refractive change or the posterior corneal measurement, or both of them. So together with Hopfer and Barrett, we did this study that is still not yet published, but will be soon. And we found that using all data, that means history and refraction, the percentage of eyes was very high, 70% again, like the best ones. And if you look at the percentage of eyes within a quarter of a diopter, 54, like a regular unoperated eye. If you added either the posterior corneal surface measurement, curvature measurements, or the historical refractive change, things were anyway better than using the no history. I know that I'm giving a lot of information. I'm coming close to the end. In 10 minutes, you will be able to give me all the questions that you need. I'm coming to something probably easier to understand, less complicated. I wanted to show you the benefits of having a combined hybrid unit in comparison to a single optical biometers that just gives you K1 and K2 and ACD and axial length, and give a few words about the cataract pre-op display of the Pentacam. This is something obvious, just a few seconds to say that having corneal topography and corneal tomography on the same machines that measure the axial length provides you 1 million of advantages with respect to K1 and K2. I will not, you already know this. You have the only toric calculator that uses total corneal astigmatism measurements in addition to the Barrett, because if you are used to the Barrett that comes from K1 and K2, you have one on the left and the other one on the right, and you can see both options. You know, everybody knows the Bellin-Ambrosio display for screening and diagnosis of early ectatic disease from first keratoconus and whatever you want to study the posterior corneal and also anterior corneal curvature of keratoconus. Something that few people know is the option to measure corneal densitometry, which is useful for any corneal scar when you see how it evolves. This is a picture from a paper we published in 2016 showing the densitometry changes after femto-LASIK, and you see the same eye on the left before surgery, and after surgery, this is an eye with an excellent outcome, and you see the scar on the edge of the flap. This is very useful when you follow keratitis or any problem with opacities of the cornea. You can quantify the lens densitometry. This is useful for many reasons. You can have a look at all the glaucoma screening with the ACD, volume of the anterior chamber. You can measure the angle of the anterior chamber, a lot of information about pachymetry and so on. And then you have the cataract preoperative display, where you see all the corneal properties. You can check the total higher order aberration, and you know that if you have aberration lower than 0.3 microns, you can implant a multifocal IOL. You can measure what we call cord mu, which is simple the difference in millimeters between the pupil center and the vertex center, so that, you know, we usually take 0.4 millimeters as the maximum value for diffractive trifocal or bifocal IOLs, and this is clearly shown in this case 0.46. You can check if the anterior and total corneal astigmatism are regular, so this is an ideal eye for toric IOLs. You can check the asphericity of the cornea, and based on corneal asphericity, you can choose the IOL model that is best for you in order to compensate such corneal asphericity that is measured at 6 millimeters, which is the same value provided by IOL manufacturers. You can compare total and corneal and keratometric astigmatism and check if the magnitude and axis are the same. A lot of information. I could spend one day course on the many advantages in the clinical routine of the Pentacam, but I would like to give you the last slides on the new wave, Pentacam AXL wave, where you see on the on this slide that it provides visual properties of the optics of the eye. This is a Scheffler camera, everybody knows. This is an optical biometry, since Pentacam AXL, everybody knows it. But it adds aberrometry, objective refraction, and retroillumination with many information. You see from the top the total visual performance, so that you can understand and show the patient how his vision is. You have the objective refraction on the right top, the aberration, the higher order aberration. You have the usual tomography. You can see the mesopic and scotopic iris image and retroillumination. And most importantly, you see the influence of total cornea, including anterior and posterior surface. And this is something that other manufacturers like iTrace and OPD scan are not able to give you. You have the quality of anterior and posterior cornea. You have the quality of the internal optics, that means the IOL or the lens. You have the total optics. This is a normal patient. And this is not a normal patient, because you see that the E is not sharp, is not good. So what happens to this patient? Where does the poor optical quality comes from? From the cornea or from the lens? Pentacam wave can do this, because you see a wonderful E on the left, so the cornea is okay. The lens, the internal optics are not so sharp, and the quality, the total optics are bad. This was a relatively young woman that had an early cataract that was not so easy to see at the slit lamp, and here you have an objective visualization, easy to understand also for the patient. This is the opposite case. You see an horrible E on the left because the lady had a radial keratotomy. The lens has no problem, but the total visual quality is affected. Some LASIK after, some striae after LASIK. You see the bad quality of the cornea on the left. Opposite case, dislocated IOL. Horrible internal optic lens, something has to be done. And this is a woman with a young woman from Japan with a subcapsular cataract after LASIK. you see that we had a 0.31 higher order aberration, which means a borderline for multifocal diffractive lenses, but she wanted multifocal. We did all the calculations after LASIK. There were some differences because the Barrett 2K provided us with 16.5, the Hill-Potvin Shamas 0.17, Olsen ray tracing 0.16. We stayed in the middle, implanted 16.5. We were lucky enough to get a planar refraction. Then she finally had a piggyback after we implanted a monofocal, and one refraction was stable. We implanted this piggyback multifocal lens, and you see that on the right, the total optics is perfect and the patient is very happy. And this was the last one. Okay, 10:46. I think that I'm ready for any question if you have any question.
Dr. Savini, Giacomo, thank you very much for this very comprehensive information. That was really, really outstanding. And thank you for sharing all this information. And of course, we got some questions and we will try to address them step by step. They are coming in now very quickly. There was a question, how do you handle the operation of the Pentacam and the IOL power calculation in your clinic? And they ask, are you doing all the examinations or do your technicians do the examinations? Can you give us some insights how you handle that in your clinic?
First year, in the very first year, I did everything by myself. Then I have the same 3 technicians since 2014, and I let them do. I taught them how to do. The machine is easy to use. Of course, I feel more experienced when I want to look at the single displays. They are technicians. They are not obliged to tell me every single clinical detail. So many times I go to the machine and analyze the data by myself. But if we are talking about just about IOL power calculation, they do everything. We already optimized the constants. They give me the printout, and I'm not doing anything. But for every patient, I do the preoperative display, I do the power distribution display, the IOL power calculation display. So I have all this PDF on my computer, and if I have any doubt, I go there.
Thank you, Giacomo. That was very comprehensive. And there is another question asking, how does the Pentacam AXL wave calculate the visual performance? So maybe that's a question that I can answer since I'm from the company. So basically what we are doing is we are measuring the cornea as a lens. Like Dr. Savini pointed out, we are measuring anterior and posterior means the total cornea. So we calculate the high order and low order aberrations of the cornea. Then we measure with the wavefront, with the Hartmann-Schack sensor, the total eye, high order and low order aberrations. And the difference between the two are the internal optics. And that's the way how we calculate in the Pentacam visual performance. And Dr. Savini, there was another question related to that last case where you talked about this lady that had LASIK before and you implanted a piggyback and then a multifocal IOL. What was a lens manufacturer? And I think if you want, you can share this information. That's up to you.
The piggyback or the monofocal?
Both.
I will tell you both. I implanted a monofocal Alcon lens in the bag. I waited for 1 month because I did not want to have any surprise. When I was sure, that the patient was okay with the refraction, I implanted a plano sulcoflex trifocal lens.
Perfect, Dr. Savini.
And I advised the patient, just to be sincere, that since without the diffractive lens, of course, she had an excellent vision, far vision. I said, please be aware that once you get, after 1 month, you get the diffractive lens, your vision for far, even if your plano will lose some contrast sensitivity, this is the price you have to pay to be able to read for near. She understood and she's happy.
Okay, perfect, very well. And there is another question asking regarding the penetration in cases of very hard and very dense cataract. Will it give the actual length or will it not give the actual length? Is there any information, experiences that you can share with us?
You will not believe me, because the Pentacam is based not on optical coherence, swept source optical coherence tomography, but based on partial coherence interferometry. You will not believe me, but we had 96% of cases in that study that were successfully measured. Sometimes this does not happen at the first measurement. You have to have a little patience and wait and maybe repeat the examination 2-3 times, but the penetration is excellent.
Perfect. Thank you very much for sharing this information. So up to now, I think we have answered all the questions which are coming in. Many people say thank you, and they really appreciate your presentation for sharing this knowledge, which is very comprehensive with us. So thank you very much. Bye-bye.
Bye-bye.